Assume that we have this circuit and we'll try to write a Verilog code for this circuit. We have two inputs having 4 bits. We can represent it like this, for example, 4 bits, and we can give a number to the bits. The most significant bit is 3, for example, number 3, and least significant bit is 0, and the same thing for the input 2. And the output is here 6 bits and 5 to 0, as you can see. And the connections are input 1 0 is connected to output 1 0, and input 1 1 is connected to output 1 1. Actually, these connections are made here 0 to 0 and 1 to 1, but I'm not going to show it like this. And below you can see input 2 3 to input 2 5, input 1 output 1 5. So that is this connection. This is connected to this, and here, as you can see, this is connected to this one. And for these output bits 3 and 2, there is a AND operation here, as you can see. Firstly, output 1 2 for this bit, we have input 1 2 and input 2 0 ended here, and it's connected to the output 1 2. And for this one, output 1 3, input 1 3 and input 2 1 is ended and it's connected to output 3. Let's try to write a code for this circuit, where I have inputs having 4 bits, input 1 and input 2, and output is 6 bit, which is out 1. I can use a sign command and curly braces. Assign output 1, and I will write here inside the curly braces the values of the output 1 from most significant bit to least significant bit. Let's check here. Most significant bit of the output 1 is actually input 2 3 and input 2 2 here, as you can see, 5 and 4, these two. So I can write here input 2 3 to 2 and comma. It means that here input 2 most significant bit, which is third, and which is, let me show you from here, these two values are directly connected to the most significant two values of the output. Then I need to write this one output 3, and for that input 1 3 and input 2 1 is ended. Input 1 3 and input 2 1 is ended here. Then I have here for output 1 2 input 1 2 and input 2 0 ended, like this, and then input 1 0 and input 1 1 is connected to output 1 0 and output 1 1, So I can write it like input 1 to 0 is connected. Now we can write a test bench. Here I define the inputs and output and call the unit under test here and make necessary connections. I will give different inputs here. I gave here two different inputs. Here input 1 is 4-bit binary 000 and input 2 is 4-bit binary 111, and after 10 nanoseconds input 1 becomes 4-bit binary 0011 and input 2 becomes 4-bit binary 1100. So let's check the output when running the simulation. Here we should analyze it bit by bit. As you can see, between 0 and 10 input 1 0 0 0 0. So let's check our schematic here. Output 1 0 and 1 should be also 0. Let's check output here 0 and 1 0 0. It's same as input 1, and the most significant bits 5 and 4 is same as input 2, and between 2 and 3 AND operation between input 1 2 and input 2 0. Since this is 1, this is 0, this is 0, correct. And again, since this is 1 and this is 0, this should be also 0. Let's check 2 and 3 are here 0. Between, actually after 10 nanoseconds, let's check the values. 0 0 1 1, least significant bits should be the same as the output, so it's correct, and most significant bits of input 2 is same as the output 1 1. Let's check, that's also correct. And in between 3 and 2 zeros, because here let's again check input 1 2 and input 2 0 is ended. Input 1 2 and input 2 0. Input 1 2 is 0, so it's ended, and again it should be 0, so it's correct. And let's check the other one here. Input 1 3 and input 2 1. Input 1 3 here again is 0, so it should be 0. So both of them, as you can see here, 0. So it's correct.